this video, we will be discussing about unique length 3 palindromic subsequences. Given a string S, return the number of unique palindromes of length 3 that are a subsequence of S. Note that even if there are multiple ways to obtain the same subsequence, it is still only counted once. So what they are saying is that in the input, we are given a string S, and now we need to count all the unique 3 length palindromes, right? Palindromes, and these have to be subsequences of this string. So basically, first of all, what is a subsequence? So a subsequence is that we can take any characters from the string S, right? Like we can skip some characters from between, but we have to maintain the relative order of all the characters. So if I take A, B, C, A, right? A, B, C, A, this is a valid subsequence. If I take A, B, this is also a valid subsequence. But if I take ACB, that is ACB, this is not a valid subsequence because we have disturbed the order of B and C over here, right? So this is a subsequence, right? Now we need to find a 3 length subsequence, right? Basically, we need to count how many 3 length palindromic subsequences are there, right? So those subsequences have to be of 3 length and they have to be palindromes. Now, what is a palindrome? So a palindrome is basically a string that if we read it from forward or if we read it from backward, it is the same. So basically, if let us suppose that my string is ma'am, right? Now, if I reverse it, then it will still be ma'am, right? Both the strings are still same, so this is a palindrome. But if let us suppose my string is ethos, now if I will read it from backward, it will be something like SOHTE, right? So these are not the same. So this is not a palindrome, right? So this is what our palindromes are. So now we need to find out a 3 length palindrome subsequence. Basically, we need to count all the 3 length palindromic subsequences and they have to be unique, right? So if let us suppose that I consider ABA, it is of 3 length and it is a palindrome. So I cannot consider this string again, right? Or this subsequence again. It has to be counted only once, right? So as I said, our subsequence has to be of length 3, right? Now, for this subsequence to be a palindrome, can I say that the first and the last character, these two have to be the same, and this can be anything, right? Because if these two characters are not same, then our subsequence will not be a palindrome, right? So if let us suppose AAC, this is my subsequence. If I write it in reverse order, it will be CAA. It is not a palindrome, right? But if my first and last letter is same and in between I have anything, so it will be same only after reversal also, right? So for a 3 length palindromic subsequence, the first and the last character has to be the same, and in the between there can be any character, right? So this is one observation that we need to consider, right? So what I can do is that in my string S, I can identify such positions, basically two indices where the character is same, right? And I can see that between those two indices, what are the unique characters, right? What are the number of unique characters that we can have, right? So that will give me the number of 3 length palindromic subsequence starting and ending with this particular character, right? So if you see over here in the string S, if let us suppose I keep a pointer I over here and J over here, so basically this is denoting the first character and this is denoting the last character. So I just need to find out this middle character, right? So between these we have A, B and C. So that means I can have 3 subsequences here, right? One will be AAA, other will be ABA, and other one will be ACA, right? Now, one thing to keep in mind is that we cannot identify it with the help of indices. That okay, I'll do their subtraction and I will be able to get the number of subsequence that it will have. We only need to count the unique palindromes, right? So within this range, we will consider only unique ones. If let us suppose there was one more A present over here, so in that case, your answer won't be 4, it will be 3 only because this will be a repeated palindrome, right? So now, how are we going to put our I and J in the string S? So what we can do is that for each character from A till Z, we will have to maintain 2 indices, right? One will be the first index which we'll keep over here and one will be the last index which we'll keep over here, right? So basically for each of these characters, I need to find 2 positions from string S, right? So if I give the indices over here 0, 1, 2, 3, 4, right? So now for each of the characters, you will have to find the position. So see, for A, we have an A over here, an A over here, and an A over here. So one of the choices that I keep my I here and J here. And the other choices, I keep my I here or J here. And the third choice is keep I here or J here, right? So there are multiple possibilities, right? So let us just consider another string to understand better. So if let us suppose my string is A, B, A, B, C, A. Right. Now here either put your I here and J here. If you will do so, you will get just one string which is A, B, A. Right? One string, remember. Then if I keep my I here and J here, then in that case you will get three strings A, B, A, and A, C, A. Right? If you see A, B, A, this one is repeated. Right? It was present when our J was here. Right? If I consider my I here and J here, then I will get two subsequences A, B, A, C, A. These two are repeated, right? I had them when my I was here and J was here, right? So instead of trying all the positions, like first keeping I and J here, then J here, and then I here and J here, what we can do is that for each of the characters, this position we can keep to the first index of that particular character in the string S. And this particular position we can keep as the last occurrence of that particular character in the string S, right? So basically, for A, I will always put my first index over here and last index over here. Why? Basically, I'll put my I here and J here, right? Why? So that I can count all the strings, right? All the subsequence that are being formed, the three length palindromic subsequence that are being formed if I consider this character to be A, right? At once, I will be able to count it, right? So now once I have fixed them here and I have identified how many unique characters are there in between, so that will give me the count of the subsequence where the character is A and A, right? The starting and the ending character is A. So then I can simply move to B now. That okay, let's identify if I put B and B over here. So I would be here and J would be here. Then how many unique subsequences am I getting? Then I can go for C, then D, and so on till Z, right? So for each of the characters, we can check this, right? So what did I say? That for each of the characters from A to Z, we will keep our eye at the first index of that particular character in string S, and we will keep J at the last occurrence of that particular character in string S, right? So what we can do is we can create a map maybe, right? We can create a map inside which we can keep all our characters from A to Z, right? And for all of these, we will maintain a pair, right? And that pair initially we can keep as -1. So this pair is denoting the first occurrence and the last occurrence. Basically, here we will keep the first occurrence of A in string S, and here we will keep the last occurrence, right? So what you can do is that in your string S, you can check that okay, the first character is A, right? So we will update the indices of A, right? Now this one in the pair, this is denoting the first occurrence, right? So we will update it only once, right? So whenever I will encounter a character, we will update the first value only when if it is -1, right? If it is not equals to -1, then that means I have already encountered that character before. So I won't be updating its first occurrence, right? So here we are encountering A for the first time because it is having -1. So we will update it to the index 0, right? And then the last value, this is the second value in the pair, which is denoting the last occurrence of A. So this will also update. Now this we will update every time we get a A, so that when we iterate the entire string at the end, this stores the last occurrence of A, right? So this one we will update only when its original value is -1, and this one will be updated always, right? Then we'll come here. Now this is 0, so it won't be updated. Only the second value will be updated. So this will become 1. Then we'll come here. Then for B, this is -1. This will be updated, and second one will also be updated. So this will be 2, 2, right? So this will become 2, comma 2. Then we'll come here. C, this is -1. This will become 3, and this will also become 3. So this will be 3, comma 3. And then we'll come here. So this is already 0. This won't get updated, only this will get updated. So this will become 2. So it will be 0, comma 2, right? And rest all the characters will be -1, -1, right? So this has to be 4, right? The index of A over here is 4, right? So this is what our map looks like. Now what we can do is that for each of these characters from A to Z, we can take this, right? So basically this will denote us the index I and this will denote us the index j, right? Now my string length has to be 3. I is here, j is here, right? So now I need to identify that how many unique characters do I have between this range, right? So basically 0, 4, 0th index is here and 4th index is here. So I will check from 1 to 3, right? That is I plus 1 and j minus 1, right? Because the 0th and 4th index we have kept here. So we will check from 1 to 3, right? So what we can do is that we can run a for loop of, let's suppose, x. It will start from I plus 1 and it will go till less than j, and we can do x plus plus, right? So here it is 0, 4. So our range will be from 1 to 3, right? That is this particular range. Now, since we need to identify only the unique characters in this range, right? So what we can do is that we can maintain a set, right? We can maintain a set, and inside this set, we can insert this particular character, right? It will be s of x. We can insert this particular character, right? So in this range, here all the characters are unique. So in our set, A, B, and C would be present. Now the size of this set after this loop finishes, it will tell us that how many unique characters were there. So if let us suppose that we have taken a variable count, so in our count, we can add the size of this set, right? So this will update that how many palindromic substrings do we have for this particular character. Then we'll move for B, then C, and so on till Z. And in the count, we will have the count of all the unique 3-length palindrome subsequences, right? So if we do a dry run over here, so as I told you, this is 0, 4. So our X will start from 1 and it will go till 3. A, B, C will be inserted inside the set. So the count will become 3, right? The count will be 3. Then we will move to B. Now this is 2, 2. So this will be 3 and it will be less than 2, right? So it won't go inside the loop because 3 is not less than 2. Then it will come here 3, 3. So this will be 4, I plus 1, right? And j will be 3, right? Now 4 is not less than 3. Again, it will not go inside the loop, right? And for rest of all of them, it is minus 1, minus 1. So if you see, minus 1 plus 1 will be 0. And this is j is minus 1. 0 is not less than minus 1. So for any of these, it will not go inside the loop, right? So at the end, your count will be 3, which is the actual answer for this particular case, right? So this is how we can solve our problem. So let's quickly look at the code. So first of all, let's take a count variable for storing our answer. Then we will take an unordered map, right? In the key, we'll take an integer, and in the value, we will take a pair, right? And that will also be integer. Let's name it MP. Then we will traverse for all the characters. So for character ch equals to A, and then ch will go till Z, and we'll do character plus plus, right? Now inside this, for each of this character in the map, we will give it a pair of minus 1 comma minus 1, right? Then we will go inside our string s starting from 0 till I less than s dot length, and then we'll do I plus plus. Now inside this, what is our current character? The character is s of I, right? Now, if its value in the pair, the first value in the pair, if it is minus 1, only then we will update it, right? So for this character ch in MP, if the first value in the pair is equals to minus 1, then in that case, we will update it to I, right? And the second value in the pair, we will update always because it will be storing the last index of this particular character, right? So once we are done with this, now we need to count the unique subsequences, right? So we will run a for loop inside our map, right? So when we will run the for loop inside our map, so first value that it will give me is the character, and the second value that it will give me is a pair, right? So this will be inside NP, right? Now, this particular pair, the first value will give me I and the second value will give me J, right? So my I will be P dot first and my J will be P dot second. So now I need to create an unordered set for storing my characters, right? So let's name it ST, and then I will run a for loop of X starting from I plus 1, and it will go till less than J, and then we'll do X plus plus. Inside this, we can simply insert this particular character inside our string. So it will be S of X, right? We will simply insert it inside our set. And once this loop finishes, in our count variable, we will store the size of this particular set. And at the end, we can return this count. So this is what our code looks like. Let's try to run this. So in this particular case, if you see, this particular for loop will run 26 times, right? Because we have 26 lowercase English alphabetical characters, right? Then this particular loop here, we are going for each and every character in the string S. So this will run n times, right? All the operations are constant inside it. Then here we are running a for loop inside our map. Now, if you see inside our map, we are updating the characters from A to Z, right? So this particular loop would be running 26 times. And then inside this, we are running a for loop for the indices inside our string S, right? So we can assume that in the worst case, it will go till n, right? The entire length of the string. So we can say that the time complexity of this approach will be order of 26 into n. 26 is constant, so we can say that it is order of n. Coming towards the space complexity, so we have taken an unordered map over here, which is storing our 26 characters, right? And then here we have taken an unordered set. Now this will also store the unique characters, right? And inside our string, the unique characters can be 26. So we can say that the time complexity will be order of 26. And since it is a constant, we can consider that the space complexity is constant. So let's try to submit this now. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.